Hi everyone, welcome to my channel. In this video, we are diving into the Linux file system, the backbone of how Linux organizes everything from system files to user data. Whether you are just starting out or preparing for a DevOps role, understanding the structure is a key. Now let's understand what is file system. A file system is a structured method of storing and managing data, including files and directories and metadata on your machine. Think of it like a library. If thousands of books were scattered around, finding one would be hard. But in an organized structure like labeled shelves, locating a book becomes easy. Same way, Linux file system is a set of process and structures that control how data is stored and how it has been accessed and organized on disk drives or partitions. Just like in Windows, we uses drives which are letters like C or D. Same way, Linux uses a single unified hierarchy starting from the root directory, which is a slash, under which all the files and directories are nested. Everything in Linux is treated as a file. There are various types of Linux file system. Types of Linux file systems have came into picture by due to their requirement and needs. Each file systems work for each requirements. So first we have a extended file version 1, and then we have come up with extended version 2, 3, 4, extended file system XFS, Btrfs, B-tree file systems, but there are so many file systems in the market. Most of the real world scenarios we use XFS extension 4. So let's see what is XFS and extension 4. XFS is mostly optimized for large files and volumes, offering superior performance and scalability. Whenever you have a large files that you want to maintain or you want to create, you want to manage, then the most of the time the file systems are used is XFS. If you want to perform various types of sizes you need, in that case you can use extension 4, but in extension 4 there is a limited efficient with extremely large files. If you have large files, then you won't be able to use extension 4. Likewise, for each requirement, for each need, we are using the type of file system in this. So if you want to use, you want to see what file system is being used in your Linux operating system, we have two commands to find out dfth and lsblkf. Let's see, I'm having now Ubuntu and Red Hat distribution. Let's see how to find this which file system has been used in our file server. So if this is Ubuntu, if you see, this is my Ubuntu operating system, and then I'm going to type dflh. So this is going to give me a detailed information about what type of file systems we are using, under which we can say directory or which devices. So here you can see the main root directory. Oh, wait 1 second. Here we have dfth. Okay. So file system type. So you can see in this type, we can see what type of file system we are using. There are different temporary file system, extension 4, virtual file system. So uh, let's see only the first one, which is our root. So root, which is using extension 4. So this Ubuntu is using extension 4 file system type. Now let's see what Amazon Linux. So I'm using Amazon Linux, which comes under a Red Hat family. So what type of file system this is using? Let's see. So you can see here also we have a type. So under root directory, we have XFS file system. So mostly in this, we can conclude that most of the distributions that we commonly use in our real-time project comes with XFS or extension 4. So this is how you have to check your file system. Let's come back to our hmm. next. Next, you need to remember some key terms in order to further uh, proceed further. So, what are the terms that you need to remember is journaling. So, in Linux, you need to remember what is journaling. What is journaling? It keeps a log called the journal. You know journal, right? So, keeping the some information regarding what you have done, what happened during this time. So that is called journaling. So that kind of information you are going to keep it in the journal that keeps track of the changes made to the file. So whatever file you are creating, you are deleting, you are adding it, you are appending some information into it, all the in logs, it is going to be it is going to keep track of that logs. And why this concept has been came, so that in case of a system failure, the lost changes can be brought back. That is why the journaling concept came into existence. So journaling is what it is, to keep a log that keeps track of the changes made to the file. Next is the inode index. Inode index is the representations of any file or directory based on the parameters, size, permission, ownership, and location of the file and directory. What does this mean? You are creating a file, right? May name file one. Now we have created the file. In the file we have data, but what about where is that file located? What is the size of that file? Whether that file has ownership or not. Uh, all the information, that means metadata about the data. What metadata about the data? That means the data about the data is being stored as the inode number. So each inode stores file type, which means whether it is a regular type or regular file, or it is a directory, or it is a symbolic link, etc. And it will store permission, what kind of permission it has, read, write, or execute, whether the file has its owner or group. The owner ID and group ID is going to be mentioned in the inode. File size, timestamp when created, when modified, access, and pointers to data block. Now, you need to, I'll tell you in a practical way how the inode is been uh, pointed to particular file which you are creating. So let's shift to your um, EC2 user. Okay, now suppose I am creating a file named file1. Okay, the file has been created using touch command. Now you need to find how the what is the inode number for this uh, file one. How to check that? You have ls hyphen I and then file name. You can see this number. This is the inode number. This represents that this file number, this file name is mapping to this inode number. So whenever the system tries to find file one, it will go and check it in the inode number. It will get all the information in this inode number, and you can see the particular file which you are trying to retrieve it. So this is how it will work, right? So in detailed form, you want to find what are the details available of this inode number. You can just use the command stat file one. You can see this is the detailed information about the particular file with inode number. So file name is the file one. We have not entered anything, so size is 0, blocks is 0. You can see inode number is this one, and when it has been accessed, when it has been modified, when it has changed, birth, all the information you can see in this state command. Okay, understood? No, so let's move on now to the next topic. So these are the key points that you need to remember whenever you are uh, going through Linux. So next, very important that you need to remember, or the just a flow you need to remember how the three-layered architectures of the Linux file system structure. Okay, so Linux file system is built on a layered architecture that abstracts complexity and ensures flexibility across different storage types and file system formats. So let's break down the three core layers, important one. Okay, and we'll see what is the role and what is the real world relevance. So first is the logical file system layer, the main layer where this act as the interface between user applications and the file system. Now, we can say that it handles high level operations like opening a file, reading a file, writing into the file, closing the file. All this comes under or manages this logical file system layer. Uh, it also manages the metadata like what is the file names, what is the permission given to the file, when the file has been created, and it ensures consistency in the file which we have created. So, for example, when you are running any command, for example, if you are running a command to create a file, right, or you are appending something into the file, the logical layer interprets this command. Okay, this logical layer will interprets this command and checks if the file exists. Check if it verifies any permission, it has the permission to read the file or not, and it initiates the read operation without worrying about where or how the data is stored physically. It doesn't worry about where the data is stored. It just gives the output whichever the command has been mentioned by the user. That's it. It doesn't care about where the data is stored, in which physical device, in which location it has been stored. No, it just verifies whether the permission is there or not, whether the file exists or not. That's it. If file exists, then it will give the output. Otherwise, no output. That's the work of logical file system layer. I hope you understood what is logical file system layer. Next, we have a virtual file system layer. It provides a unified interface for different file system, right? Now we have different types of file system, and in one server we can have different types of file systems. So all different types of file system can be managed simultaneously with the help of this virtual file system layer. It allows Linux to support multiple file systems simultaneously. uh, this is the main function of virtual file system layer. For example, you can say your home directory is working on file system extension 4, and your other mount or device backup directory is working on NFS, network file system. What VFS do, it will lets you access both seamlessly using the same command, even though they are backed by different technologies. So that is the main responsibility of virtual file system layer. Next, we have a physical file system layer, which is very important, which manages the actual data blocks on disk, which will decide which data needs to be put on which memory, which blocks, which partitions. Everything is decided by physical file system layer. It handles low level tasks like block allocation, journaling, and disk IO. It directly interacts with the storage hardware, HDD, SSD, USB. For example, you save a file, right? You are saving a file with some comment. What does this physical layer does? The physical layer decides where on the disk to store this data, updates the inode table, and ensures the data is written reliably, possibly using journaling if you are on extension 4. So this is how the flow goes on if you are working in Linux file system. Hope you understand what are the three layered architecture. This is the end of this video. In next video, I'm going to tell you about what is the hierarchy of file Linux file system. We'll be exploring more about what are the directories and files available in Linux. So this will be going to be very important topic. The next video. If you like this video, please like, share, and subscribe this video. And in the next video, we'll be exploring more about what is file system hierarchy. Thank you so much. Thank you for watching.